Roberto. I'm a senior here at Central Washington, and for my senior project, I'm working on the drivetrain and chassis portion for the RC Baja vehicle with my partner Roberto, who is working on the steering and suspension portion for the vehicle, which will later combine to compete in two events, the slalom and sprint event and the Baja event. So the motivation for choosing this project was because I previously had no experience working with drivetrains or with gears in general, so this was a great opportunity to gain hands-on experience working on a smaller 1/8 scale version of a full-scale drivetrain, as well as being able to apply the things that we've been learning in mechanical design and seeing what sort of improvements could be made to the drivetrain throughout the year as more information was being learned about the drivetrains and how to design them. And so during the process of designing the vehicle and its components, many analysis had to be done, which required the use of various engineering methods such as the use of dynamics, which was used to calculate the impact force at the vehicle traveling at its maximum velocity, as well as the use of mechanical materials to calculate the buckling load of the chassis to ensure that there will be no buckling during the impact testing of the vehicle, as well as for the drivetrain, mechanical design was used to calculate the train value for the drivetrain to ensure that the vehicle would reach its maximum velocity of 30 miles per hour. And so, taking a look at the schedule for the project. Here we have the fall schedule where the main focus was on writing for the proposal of the entire project, as well as the design and the analysis for various components of the drivetrain and the chassis, as well as the documentation which were used in the proposal. Following that, in the winter schedule, here the main focus was on the manufacturing of the components, as well as the complete assembly at the end of the schedule. And then after that, in the spring schedule here, the main focus was on the evaluation of the completely assembled vehicle, as well as the finalization of the proposal and the web design. Some of the important tests were the drop test to ensure that the vehicle would withstand an impact from the 2 feet drop, as well as an impact test to ensure that the vehicle would withstand its maximum velocity, the impact at its maximum velocity, as well as the steering angle test to ensure that there is enough maneuverability to ensure that the vehicle would not hinder any performance in the slalom and sprint events. And so for the budget of the project, here we are currently sitting at $335.187, which was roughly $165 under our maximum budget, which we had stated to be $500. However, we are estimating that by the end of the winter quarter, we are going to be fairly close to our $500 limit. And then for the reason why we believe that the project is going to be successful is because of all of the analysis that has been done throughout the year. Because each analysis was done to ensure that the vehicle met a specific requirement. For example, here in analysis 2, the minimum front cross-section area was determined to ensure that the vehicle was able to withstand the stress and the impact from hitting a wall at 30 miles an hour, which met requirement 1D9, which stated that the chassis will withstand an impact at 30 miles an hour. Then taking the cross-section area and calculating a deflection to ensure that requirement 1D13 was being met, which was our deflection requirement, which stated that the chassis would not deflect more than 0.1 inch at all times. Following that, in our analysis 1 here, a gear ratio analysis was done to determine the train value that would ensure that the vehicle would achieve a maximum velocity of 30 miles an hour. And we need requirement 1D7, which stated that the drivetrain can reach 30 miles an hour. Then in analysis 11, here, the main focus is on meeting requirement 1D10, which was stated to be the chassis will not buckle under the force from an impact at 30 miles per hour. And in analysis 3, here the purpose was to calculate the deflection to ensure that the deflection requirement 1D13 was being met, which stated that the chassis will not buckle under more than 0.1 inch, and this was for the drop test. And so with these and the other analysis that were performed throughout the year, we predict that the vehicle will be successful during the testing that will occur in the spring quarter. Thank you.